surveying, and also we'll see briefly about total station. When we are doing this compass surveying or using theodolites, what we usually do is we note down the readings on the field and then plot it later. But plane table surveying, we do both of them simultaneously. That is, field work and plotting is done simultaneously. So that is plane table surveying. So we'll have different instruments. So usually plane table is nothing but it is a drawing board mounted on a tripod. And then you have various instruments which we'll be seeing later, with the help of which you can graphically plot these diagrams, and in the end you will produce these topographic maps. So this is a method of cartographic surveying where we are graphically producing these topographic maps. So as you can see from the image here, this is known as a alidade. So it will have an sight vane and object vane, and suppose you want to set out this point. So what you do is you sight with the help of the sight vane and try to fit in the object within this object vane, and then you draw this rays, and then you measure the distances and scale it down and cut it off here. So with the help of that we can survey this area with the help of this plane table surveying instruments. Now let us see about some of the instruments used in this plane table surveying. So we saw about this alidade. So it is essentially to mark the direction of lines. So that is what we saw in the earlier slide also. So suppose you have this instrument set out at point A, you try to sight point B through the sight vane and then draw the ray C, and then you sight out point B and draw the ray B. And if suppose you measure the distance with the help of some external instruments, you measure the distances, let us say it is 100 meters, you scale it down and cut it off here. Let us say this could be 10 centimeter, and if this is 200 meter, it is 20 centimeter, and you cut the rays here in this drawing board. On this drawing board, you will usually have a drawing sheet which is mounted with the help of pins, and then you will sight and draw these diagrams. You have plumbing fork which has a U frame like this. So the center of the table, you can mark it down here. And then you also have the spirit level which will help you in leveling. There will be a bubble, and you measure it at, you keep it at two places in a plane table and make sure that they are at the center. And with the help of that, you can level the table to the horizontal plane. And then you have the trough compass which will help you in identifying the north-south direction, that is your magnetic meridian. And we have also another instrument known as clinometer which will help you in measuring elevations. So here you will have an eyepiece, and then here you have a sliding hair, and whenever this object is sighted, whichever object you want to sight, you move this sliding hair so that it gets intersected. Then you can measure the angle, and if you know the distance, you can measure the elevation with the help of this clinometer. So for setting up the plane table, the important steps are, one is centering with the help of this plumbing fork, and then what you do is, and then you level it with the help of this spirit level. So then the next step is leveling. Then the last step is orientation. Orientation means positioning the table. So whichever direction you want, you should position the table appropriately, and when you shift the table also, you should make sure that it is in scale. Suppose you want to shift the instrument to this point B. So after you shift this plane table, you try to sight this point A back and make sure that they are in the same line. So you keep on rotating the table unless these two are in the same line. So in that way, you can orient the table. Now let us see about the different methods of plane table surveying. So we have radiation, traversing, intersection, and resection. So we'll see about all these four now. So the selection of any of this method depends on the visibility between stations, visibility of the station from the instrument station, and also if we can locate these stations easily. So based on that, any of this method is used. Now first let us see about the radiation method. So this is used when all the stations are visible and accessible. So what you do is you set up the instrument at O, that is whichever is your center, and then you draw the rays to B, C, D, and A, which is what you want to plot. So that you can use that alidade and draw these rays, and then after measuring the distances, you can cut these rays down, and if you join these points, you will get this close traverse A, B, C, D. So this method is known as radiation, where you are radiating the rays. Then you have another method which is known as intersection. So this is used when it is not possible to measure the distance between stations, like in rough terrain. So what you do is you select two stations. Let us say you select A and B. So these two are of known points. So these are known points. And first you draw this baseline with the help of alidade, and then when the instrument, when the plane table is here, you sight point C and draw this ray. And when the that is up to the paper only it will be that, and you shift the instrument to point B, and then you make sure that it is in the same line as AB. You should orient the table in such a way that this AB is equal to this AB, that is these rays are at the same place, and then you cite point C. So already you have this. Then if you draw a ray to C, so that intersection will be your C point. So this method is known as intersection. Then you have traversing, which is similar to compass or theodolite surveying. So here what you do is you set the table at each of the station. First you set the table at station A, site point B, measure the distance. So you have AB. Then you move the instrument to B, backside AB, and make sure that you orient the table, then site point C. So like that you can keep on going. So this is usually suitable for narrow strips of terrain like highway, railways, etc. Then you have this last one, which is known as resection. Resection is like completely opposite to what we saw in intersection method. Here we try and locate the position of plane table which is unknown. Suppose we want to locate a plane table point which is unknown, then we go for resection. So we have different methods here. One is resection by back ray, resection by 2 points and 3 points. So this back ray intersection orientation we saw earlier also. Suppose we know these points A and B, then we can draw this line AB, and then from here, suppose we want to locate and plot the position of this unknown point C. First you try and sight C from point A. So then you have this ray here. So then you take the plane table to C and try to backside this ray A. So unless it comes in the same line, you keep on rotating the table, then you can fix the position of point C. So that is resection by back ray method. Then you also have resection by 3 points method. So here what we have is 3 well-defined points A, B and C. So here what first initially we fix T dash as the point which we assume that it should take. Then you orient the table along T dash A. Then you sight this point B and draw a back ray. And similarly you sight this point C and draw a back ray. So whatever triangle it forms, so that is your triangle of error. And we keep on minimizing these errors by changing the points of T dash. So this is a trial and error method where we try to minimize this triangle of error. It is also known as Lehmann's method. And in case of resection by 2 points, we'll just use 2 points. So obviously this 3 points method is more accurate than the 2 points method. So this is about resection. Now let us see advantages and disadvantages of plane table surveying. One advantage is that obviously plotting and observation is done simultaneously. So this saves a bit of time, and also there will be no risk of omitted measurements because we are plotting there itself. And any errors can be found out by drawing this check line. Suppose we have a closed traverse, position the plane table here and sight this point C and make sure they intersect. So with the help of these check lines, we can check then and there, and this is very rapid. And also wherever this compass surveying is not suitable because of some magnetic field, this will be more suitable. And the main disadvantage is that you cannot replot it to a different scale because already it is plotted and you don't have the measurements. And also it is not good in wet climates or in woody areas where you cannot position the plane table. And this carrying instruments, all the instruments of this plane table is cumbersome. So these are the advantages and disadvantages of plane table surveying. Now let us see briefly about total station. So total station is a digital form of doing surveying. It is nothing but a combination of electronic theodolite and electromagnetic distance measurement, which we saw earlier. So this is widely being used nowadays for surveying. So with this electromagnetic distance measurement, earlier also we saw that we can measure the distances very easily in digital manner by sending out some rays and calculating the time it takes to come back. So that will give you the distances, and with the help of electronic theodolite you can calculate horizontal and vertical angles digitally. So this electronic theodolite has the same concept as a conventional theodolite. Only thing here is that you will have the same horizontal circle, but it is digitally encoded. This horizontal circle will be encoded in such a way that when you pass light through it, it will form a sort of pattern, and that light pattern is detected by photodiodes, and then it is read electronically, and that will give you the digital measurement of horizontal and vertical angle whichever you are trying to measure, and then it will display here. So this is how a total station looks like. And apart from this, we will also have one more thing which is known as retroreflector. So whatever point you want to measure, so retroreflector is nothing but something which is mounted on a pole. So whatever waves sent out, it will be passed back parallelly and there won't be much errors. So that will be useful here. So now we know distance, horizontal and vertical angles are there, so we can know the elevation also. So with the help of all these three, we can plot the x, y, and z coordinates. So you'll have all the three coordinates, three-dimensional coordinates you will be having in case of total station. These data, whichever you do during survey, they are stored in cards and they can easily be transferred to computer. So with the advent of this total station, everything has become faster and easier.